Now we're going to look at a couple examples where we want to determine whether a line is parallel, perpendicular, or neither. So let's say we have one line is described as x minus 3y equals 6. That's shown here. And in this case it has a slope of 1/3. We have another line of 2x minus 6y equal negative 12. That's shown here. And we'll solve for each of these equations to see what the slope is. I calculated each of these equations before, but they're equal to 1/3. Since they have the same slope, they are parallel, and they also have different y-intercepts. So solving in the top equation here, x minus 3y equals 6, we want to isolate y as our objective. We subtract x from both sides of this equation. The x cancels out on the left side, and here we have negative 3y and 6 minus x, so we divide by negative 3 to isolate y. We see the 3's cancels on the left, and that yields a y-intercept form of y equals 1/3 x minus 2. So here we see the slope here is 1/3 and the y-intercept of negative 2. Okay, so a slope of 1/3 and a y-intercept of negative 2. Now let's solve this one. 2x minus 6y equal minus 12. Okay, so here we have 2x minus 6y minus 2x is equal to minus 12 minus 2x, where we subtracted 2x from both sides of this equation. We see the 2x's cancel on the left side once again, and we have now negative 6y equals negative 12 minus 2x. To isolate y, we divide by negative 6, and we see the negative 6 cancels on the left side, and we have negative 6 divided by negative 12 divided by negative 6 is equal to 1/3 x plus 2 when you perform this operation on the right side. So here's negative 2x divided by minus 6, that's the 1/3 here. Negative 12 divided by negative 6 is equal to 2. So we see here we have a slope of 1/3 and a b of 2. This is the y-intercept. So it intercepts this axis. Alright, so that's our equation for that line. And so therefore, because they have the same slope, they are parallel to one another. Now again, to see this slope of 1/3, we can see that this is positive 1/3. So if we go 3 units to the right, we go 1 unit up, as shown here. So 3 units to the right, 1 unit up. 3 units to the right, 1 unit up. So therefore the slope has 1/3. Remember, it's the rise over the run, or the change in y over the change in x. So we have a change of y of 1 here over a change of x of 3. That's why the slope is 1/3. And we note that these lines are parallel once again with different y-intercept points. So in summary, when lines have the same slope and different y-intercepts, they are said to be parallel lines. Let's look at another example, how we determine whether a line is parallel, perpendicular, or neither. Here we're given a linear equation, 2x plus y equals 6. That's governed by this line. Has a slope of negative 2, which we'll see later. We have another line, x plus y equal 4. That's shown here. And that has a slope of negative 1. So solving for y to isolate it, so we have it in slope-intercept form, we have the following, where we subtract 2x from both sides. The 2x cancels, and that leaves the following equation, where y equals minus 2x plus 6. Here we have a slope of m equal minus 2 and a y-intercept of 6. So in this line, 2x plus y equals 6, we have a slope of 2 and it intercepts the y-axis at 6. Again, here the slope is negative 2, and we can see that as we go like 1 unit to the left here, we go 2 units up. And that y is defined as negative slope. Now the other equation, x plus y equals 4, we subtract x from both sides. Now we have y equal 4 minus x, interchanging using the commutative property. We have y equal minus x plus 4. Here we have a slope of negative 1. And we see that the y-intercept is 4. So here we can see the slope is negative 1. When we go 1 unit to the left, we go 1 unit up. That's our slope of negative 1, and it intercepts at 4. But since the slopes are not equal, and it does not equal negative 1, then we say that this line is, these set of lines, these pair of lines, are not parallel or perpendicular. So one more final example, parallel, perpendicular lines, or neither. We want to determine whether a pair of lines is either parallel, perpendicular, or neither. So let's say we're given an equation 2x plus y equals 5. And that's described here as a slope of negative 2, which we'll see. We have another line at x minus 2y equal 4. And we have a slope of 1/2. So here we have a positive slope of 1/2 and a slope of negative 2. And note their products is equal to negative 1, so we can say that they're perpendicular. But let's go through the algebra associated with these lines. 2x plus y equals 5. Again, we want to isolate y so we can have it at slope-intercept form. 2x plus y minus 2x on the left side equals 5 minus 2x on the right side. We see that the 2x's cancel, leaving y equals 5 minus 2x. And now we have y equal negative 2x plus 5. So we have a slope of negative 2 and a y-intercept of 5. Okay. The other equation, x minus 2y equal 4, here again we subtract x from both sides of this equation. That leaves the x canceling each other out, leaving negative 2y at the left side, and then 4 minus x on the right side. We divide by negative 2 on both sides of this equation. We see the 2's cancel out on the left side, and that leaves y equal 1/2 x minus 2. Now the 1/2 x came from here, where we divide negative x divided by 2, which is the same thing as a positive 1/2 x. Then 4 divided by negative 2 yields negative 2. Now since this is already in slope-intercept form now, we say that it has a slope of 1/2 and a y-intercept of minus 2. Now we look at the product of the slopes, and they equal to 1, as said earlier. So here we have negative 2 times 1/2 equals negative 1. Therefore we can say that these lines are perpendicular. So let's look at that application involving slope. Here in this case we have escalating healthcare costs governed by the following equation. C equals to 7t plus 127, where C is the total cost and t is the number of years after 1980. So what is the slope C? Well, we already recognize this as a slope-intercept form. So the coefficient in front of t is 17. What does the slope represent? Well, it represents that the annual increase of $17 per year of daily room charge. And that concludes the application involving this slope.